So this is another video in the series of the Octagon set or space ecotourism. So here we have the tank valve, which is part of the plants or the infrastructure. And what I want to show today is the difference between, I'm going to call version 1 of the internal workings of the quick release mechanism for the tank valve versus version 2, which you can see is a lot bigger. I guess we'll start off on the back side just by saying, hey, this is version 0. This is an early prototype done earlier this year. Which the complete approach to this was completely abandoned for a variety of reasons. Also, I bought TPU, which is a flexible filament, in order to be able to do things like washers and stuff like that and start to seal. Did that for another project, but you can see, actually it was only available in translucent or transparent yellow, so I figured I'd go for the bumblebee look. And if we look at that, obviously we have the ball here that is designed to close the tank, while the quick release knob is inside. Obviously we've got some washers there designed to seal it when it's stuck on the inside. So two ways of doing it. One is to put a washer to close the ball that is made of plastic, and the other one is to have the full ball made of plastic. Eventually this whole valving mechanism I want to use in a pump, and if it's going to cycle plastic on plastic is going to rattle quite a bit. So anyways, one of the two strategies is probably going to be required. So yeah, so those are a few little minor advancements as we move from version 1 to version 2. Version 2 is not completely assembled yet. I'll have another video on that a bit later, but right now we'll just dive into the differences between version 1 and version 2. So in both cases we have basically a bunch of stacks, and the purpose of the stack is to actually, this is version 1 here, is to have a seat for a bunch of gears. So here we have the pushing mechanism, this guy over here. The idea is that this comes, it's going to fall apart underneath, but the idea is that it turns the first gear, which turns this angle rod, and then turns this push rod. Now obviously from the previous video, the gears are very small, the tolerances are not tight enough for this whole thing to turn, and the gears kept breaking, so this is why we went to version 2, which is bigger. So I guess we're going to start off the same. We've got the same springs that are actually in a semi-coiled fashion, so I had to cut it, but this is what the springs fit into version 1, into these little holes here. That little hole right there. And on the inside of it, it looks the same thing as this. I had to cut it at a different location. 4 key slots means that we're going to have 4 rails, and that's to pinch the actual slider tube that does the quick release. So we're going to have 4 of these little gears, and the idea is to pinch it so that we don't have any slippage between this first gear over here and the inside. So here the important part, and what is the achievement, I guess, is if I turn this overall outside gear, we're going to see that the angle gear here is going to turn. But there's also a huge simplification on this guy in that if there's not 3 gears anymore, or there's not 2 linkages, there's only 1. So the best way to demo the fact that this was a good change is if I push down on the gears that are here. Oh, I gotta find the right side. Let me switch hands here. If I push down on this guy, you're gonna see that the other gear on the top, this gear over here, turns. And obviously vice versa. So this was, I'll say, version 2.1 of this gear, which didn't work half as well as version 2.2. And I'm going to switch hands again because I'm already, the next step is to print version 3. So you can see as I'm moving along, I'm getting better. There's less resistance to the whole, in the whole mechanism. Although there still is some. So version, I don't know, 2.3 if you want to call it that, will have as its goal reducing the resistance that we have here. Okay, so once again, this time it's completely symmetric, so we're going to have 2 buttons. The extra space has allowed me to go 2 buttons, and the idea is the same rack concept. It's going to obviously have to be bigger than this. We'll wrap underneath. I haven't printed the new rack, but it's just a bit bigger, same concept, and you know, we're going to have the pinion, or the rack, sorry, run over the wheels on this side as well as on that side. So the same as well as on this side. So one of them is going to be like this, and the other one's going to be like that. But more on that in another video. The main purpose of this video was to crack open this guy over here and kind of show what was done. So you can see there's already differences between, I've already cut these pieces off, and that's for final assembly later on. So you could say, you know, I'm already moving on to version 4. I need both my hands very quickly just to put a screwdriver in to wedge open this whole thing. Okay, here we go. So as we open this guy up, same concept as before. We have the insert or the inset, and then we've got, this is called the cover in terms of the names of the files, and obviously this just fits on top of these individual pieces. The big achievement, again, this rough gear here where this edge is cut off, is the version 1.1, but if I turn it, you can see that I'm getting some, I can turn it one way without it popping out, and I'm getting some traction. But even here on this guy, I'm getting some slippage. But on this side over here, you're going to see that it's, if I turn it so that it spins it inside, you can see that I'm not getting any slippage. So what happens is that as we print, the outer diameter of the small rods end up being smaller, so therefore the tolerances are tighter. So on the diameter, not the radius, I'm actually using a 0.2 size difference. But when I move to a large diameter like this, that was too tight, so I had to move back to 0.4 on either side, which is going from 0.2 on the diameter to 0.8. So on the radius, this is 0.1 on either side, and then over here on the big spinning parts, it's actually 0.4. One of the main causes of resistance is the fact that this is very narrow, so I've got a lot of friction, I've got a lot of surface area. So on the next version of that, we're going to blow that out. So on this guy here, I cut it out so that we can actually get this thing to spin. And on this one here, I had in the actual design files, the disc wasn't touching, so therefore it just broke apart. So it was just a design error on my part. But effectively, you know, here's how it would sit in. But it's not required for this overall demo. So a couple of key points here. This is fully symmetrical. So one of the questions could be, you know, why don't we have gears over on this side? One of the reasons is that if I roll this in the direction to push it down, I want this thing to be pushing this guy down for the quick release. This one is actually going to push it up. So we can only use 2 at the same time. But in order to get the pinching that I was talking to you about, I'm going to print one of these guys without the head, seat it in there as a gear, and then hopefully I get the pinch and the pinch on this side so that we get good traction. And again, I got 2 racks, one on top and one on the bottom of each of these wheels, top and bottom, top and bottom. And hopefully with that, I'll have the mechanical strength to push this guy down and the isolation. Now, this is beveled. I did that to, you know, get some additional tolerances here. But if you look at the way there's mechanical strains on here, it could very well be that this will turn out to be a good idea. And I'm expecting as time goes on for these holes to wear out. If the gears wear out, that's fine, you turn them, you just print a new one. But if the holes wear out, then what we can do is actually just turn this around, put it on this side, and instead of having it mounted on the valve, you know, this way, and you drop it into the seat of the valve, you just flip it around, and now you got, a whole new life at the same thing, because once again, this design now is completely symmetrical. So I wanted to take the opportunity to just have a quick video to explain this, to basically state the tolerances, mostly so that I don't forget. And when we do the printing, this is going to have its outer sleeve, which is this as a separate piece, but it's also going to be, well, this bottom part, which is where the button sits, and the top part are going to be two pieces, and I'm working on the mechanisms to connect the two. So hopefully you'll see that very shortly, and a few other improvements and other design elements. Until the next video, this is Steph signing off.